Hello, everyone. Today we're going to be looking at the difference between what we know as a statistic and something else called a parameter. And so to start, I want to go over this one example that will kind of lead us into this definition of a statistic versus a parameter. Okay. So it says at one point, a Gallup poll found that 57% of Americans had bought a lottery ticket in the previous 12 months. They randomly selected 1,523 adults. This finding from 1,523 adults makes a claim about the 235 million adults in America at the time. So we've talked about this many times or at different times in our course, and that is that typically when we are taking a survey, obviously it's almost impossible to get a consensus. Consensus being that you've heard from everybody in the population. So you take a sample of people and then you make assumptions about the population, or maybe estimations is a better word. And so that is a statistic when we take, again, a sample to make an estimate about the whole population. But there are certain situations when a data point is a parameter versus a statistic. So a parameter is a number that describes the population. A parameter is a fixed number, meaning it doesn't change, but in practice, we don't know its value. Whereas a statistic is a number that describes a sample. So a lot of pretty much everything that we've done here in this course has been working with statistics. We haven't been working with parameters. But it says the value of a statistic is known when we have taken a sample, but it can change from sample to sample. We often use a statistic to estimate a parameter. Okay. So one thing I want to just kind of stop on here for a second is the second sentence where it says, but it can change from sample to sample. Okay. So think about this survey that they took regarding lottery tickets. What that's saying is that theoretically, if they were to sample 1,523 different people, they could, and I think it's pretty likely that they get a different result than 57%. Okay. And then they could survey another 1,523 people and get a different result. And so that's one thing with statistics is statistics can change depending on who is surveyed. And that's, what we've been talking about here in this chapter is that's why we need to make things as fair as possible, because they can change from survey to survey, but it can't be because of bias or anything like that. So let's look at an example comparing a statistic and a parameter. So it says determine which bolded number is a parameter, which is so it says on New York to Denver flight, 8% of the 125 passengers were selected for a random security screening prior to boarding. According to the TSA, 10% of airline passengers are chosen for random screenings. And so this 8% is a statistic because that is an actual sample. That is actually what happened on this particular flight. And so in this case, the flight itself is considered the sample. And on that sample, 8% of the 125 passengers were surveyed. Now, keep in mind that on this particular flight, it was 8%. But if we chose a different sample, meaning if we chose a different flight, then maybe that flight was 12%. And so, for the airport, it's the goal is to screen 10% of the flight people flying, but from flight to flight or from sample to sample, that number could be bigger or higher. But again, 8% is a statistic because it's an actual data point from an actual sample, whereas 10% is what we call a parameter. So 10% is kind of the goal, and that's what you can think of as a parameter. This is what the goal is, but that might actually be different from the statistic. Okay. And so that's kind of all I have for you today. This 6.3 is really just identifying the difference between a statistic and a parameter. And so again, to summarize there, a statistic is something that's found in a sample by taking a sample, and a parameter, kind of a loose definition of that is what the actual goal of the data is supposed to be. Okay. So again, this was 6.3, so go ahead and work on that assignment.